Hello, everybody. You're welcome to the Tuition Centre, Maths Higher Level Leaving Cert 2021, Paper 1 Pre. I'm going to go down through all of the 10 solutions to our questions here, the 6 short questions and the 4 long questions. So there'll be an individual video for each one of them. I'll start off here on question 1, of course, the first question that these students would have faced in the exam. We're hoping that, this 30-mark question, when you flipped it over and looked at it, you'd say to yourself, okay, we know what this looks like. It's a function. It's a cubic function, f of x equal to minus 6x cubed minus 7x squared plus 40x plus 21. So what do we say here? Well, we need, for part A, we're just asked to show that x plus 3 is a factor. Well, we can show that x plus 3 is a factor by doing a long division. We could divide x plus 3 into that cubic, and if there's a remainder of 0, well, then it is a factor. Or alternatively, you could say, okay, if x plus 3 is a factor, then minus 3 is the root. So by putting minus 3 in where you have x, you should get an answer of 0, and that in fact is what happens here. When we sub in minus 3 for x, we get 0, and of course that tells us that minus 3 is a root and x plus 3 is a factor. So that's 5 marks. Now, we're then asked to factorize f of x completely. So we can do the long division here at this stage. So we look at our first term here, x, we divide it into the minus 6x cubed. So it goes in minus 6x squared times. I multiply down, I get minus 6x cubed minus 18x squared, line underneath, change the sign, plus becomes minus, or minus becomes plus in both cases here. Of course, the first ones always cancel. I end up with 11x squared, I bring down my 40x. Again, it's my first term here, dividing into my first term here. So x into 11x squared goes 11x times, I multiply down again, I get the 11x squared and the 33x. What happens next? I have my line underneath. Again, I change my signs to negatives in this case. The first ones cancel as always. I have my 7x and my 21. I'm looking good here now because x divides into 7x 7 times. When I multiply down, then I get 7x plus 21. Change the signs. I have a remainder of 0. So I'm very happy because I've divided in correctly. I know that by the fact I have my remainder of 0. Again, showing that x plus 3 is a factor. But also, we know that what's on top here, the quadratic minus 6x squared plus 11x plus 7 is also a factor of the cubic. And together, when I multiply those together, they would in fact give me back the original cubic. Now, of course, some of you, I bet, prefer the array method, the grid method. And how this works with the grid method, for those of you who aren't, quite as familiar with it as others. Some people swear by it. I'm a long division man myself, but some people love this. So what you do is you're looking back at your original cubic, and basically you're bringing it into this array here where you have in this first box, as we see here, we have our power of 3 term. And then in these 2 boxes, then I'm going to have my x squared spread out over those 2 boxes. And then these 2 boxes will have my x term. And finally, in my final box here down the bottom right, I'll have my constant. So what do? I kind of start off in the same way. X into minus 6x cubed goes minus 6x squared. And I multiply down in the same way, minus 6x squared times x gives me my minus 6x cubed, and my minus 6x squared times my 3x gives me my minus 18x squared. But I know that I need a minus 7x squared. So to have a total of minus 7x squared in my other box that relates to the x squared, I'm going to have 11x because minus 18x squared plus the 11x squared would give me my minus 7x squared as required. I then again look at my first term here, my x and my 11x squared. And when I divide in, of course, I'm going to get 11x. I then do my multiplication again. So I'm going to get 11x times x is 11x squared, 11x times 3 is my 33x. Where did that 7x come from? Well, I know in this case that in total I need 40x. So my 33x and my 7x combine to give me my 40x. What do I do? Well, x into 7x is going to go 7 times. And when I multiply down by the 7, I'm going to get 7 times x is 7x. 7 times 3 is 21. So now when I put all these terms together, I would have my original function. But what do I have up here on top? I have my quadratic factor, the exact same as I had up here. Whichever way you did it, if you're on track, you now know that your function, which was a cubic function, can now be written as x plus 3 times minus 6x squared plus 11x plus 7. So that's my linear times my quadratic. My quadratic can be factorized down into 2 more linears. Those are my 3 factors, and which together multiplied will get me back to my original f of x. And in fact, so I have now factorized completely, and I have my 10 marks. The next part, part C, asks me to solve f of x equals naught. So I could do it in a number of ways, but the way I'm going to do it here is I'm just going to use my factors. I know that, for instance, if my original function is equal to 0, it was a cubic, well, I could have my original linear times my quadratic would be equal to 0, or my 3 linear functions multiplied together would be 0. 3 things multiplied together equals 0. The only way that's possible is if the first is 0, or the second is 0, or the third is 0, as I have down here. When I solve that, then I get x equals minus 3, x equals 7 over 3, and x is equal to minus a half. Now, these numbers are going to be important for the second, or the last part, I should say, of this question, part D. So it was a 5 marker here for part C, relatively easy once you had part B done correctly. This last part, part D of this question, is a question type that used to come up quite often before. Using your answers to part C, kind of like a hint or otherwise, or, following on from, solve this equation. So when you look at this equation here, it obviously looks a bit complicated. You've got these 2 times 2 to the power of 3y, 2 to the power of 2y, 2 to the power of 1y. You've got it equals, you have, numbers that obviously look quite similar to the coefficients here, but some of them have different signs. In a question like this, what you'd always do is you try and make what you have in the question look like what you had in the previous part. So I'll rearrange. So I'm going to do a couple of things. Number one, my first step here is I'm going to say 2 to the power of 3y can be written as 2 to the power of y all to the power of 3. 2 to the power of 2y can be written as 2 to the power of y all to the power of 2. What happens next? Well, I can then rearrange this equation to have the coefficients looking exactly the same as I had up here at the very top. So it's minus 6 times 2y to the power of 3, minus 7 times 2y to the power of 2, plus 40 times 2 to the power of y, plus 21 equals 0. What do I do then? I'm going to use this trick where I'm going to say, I'm going to let 2y, or 2 to the power of y, equal x. And why I do that is because it then makes the question look easier. Well, yeah, it would make the question look easier, wouldn't it? Because what would it look like? It would look like back to what I had. So minus 6x to the power of 3 minus 7x to the power of 2 plus 40x plus 21. And I know when I solve that cubic equation, I got 3 answers. I just have it written down here, minus 3, 7 over 3, and minus a half. So in that case, 2 to the power of y could be equal to minus 3, 2 to the power of y could be equal to minus a half, or 2 to the power of y could be equal to 7 over 3. But a little bit of knowledge of indices would tell me that neither of those first 2 will work. And the reason neither of those first 2 will work is because there's no number which I could sub in for y which would make 2 to that power equal to a negative number. So this is the only one I have to worry about here. 2 to the power of y equals 7 over 3. Now, if I have 2 to the power of y equals 7 over 3, I have an index equation. My variable is the power, that's y. How do I solve any equation? I isolate the variable. Now, typically what I do in this case is I'll actually use what I call the key rule of logs, which is this. If a to the power of b is equal to c, that implies the log of c to the base a equals b. What's happened there? Well, what's happened is when I've gone from indices to logs, the base remains the base. What was the answer becomes the power. What was the power becomes the answer. So it switches place. And by the way, this also works here with the implication going the other way. So you can go from logs to indices using the same rule. So over here, if I have 2 to the power of y is equal to 7 over 3, I introduce logs. The base remains the base. What was the answer becomes the power. What was the power becomes the answer. All I got to do is type this part into the calculator, and I think I'm going to get an answer of 1.22 equals y. So if you haven't seen that before, you might want to just rewind back and look at that again. I find that a very useful way of doing and solving indices questions, indices equations. So in this case, I can say I can do it another way, which might be more common, where I'll introduce logs. So I'm going to take log to the base 10 of both sides, typically called log. But I'm just writing it in here fully because we know if I've 2 to the power of y all to the base 10 in log, so log 2 to the power of y to the base 10, I can bring the y to the front, bring the power to the front. So I'm going to have y times log of 2, and remember that's log of 2 to the base 10 equals log x to the base 10. We know that log is shorthand for log to the base 10. I can divide across by my log 2 to the base 10 because, and by the way, we're putting in the 7 over 3 for x because that's the only possible valid solution. So I'm going to divide across by my log to the base log. I'm going to divide across by log 2 to the base 10 or log 2. I'm going to get my answer here, which is 1.22 with all the decimals. But I'm careful to look back here. I don't want to lose my 1 mark for rounding. So correct to 1 decimal or to 2 decimal place, my answer is 1.22. And that was a 10-mark question. What would I say? Like a lot of times you hear me say, it's easy enough when you know how. It looks more difficult than it is. But there it was for 10 marks. So I'm thinking that was probably a popular question, and we'd be very interested to see from the feedback how people got on with that. Okay, that's question 1. Let's move on to question 2.